Good morning all. I am Anamika K from MSc at Physics. Today I am going to present my seminar on the topic Structural Features of Nanoparticle with comparison to bulk material. This topic comes under the nanoscience and condensed matter physics. Nanoscience is an important and rapidly growing area of modern physics, and understanding the structure of nanoparticles is very essential because structure is the base of all physical property. Now I will start with a brief introduction. Nanoscience deals with materials at the nanometer scale, that is, material having a dimension between 1 and 100 nanometers. At this scale, material do not behave like bulk solid. Instead, they show new structural and physical behavior. Nanoparticles form the basic building blocks of nanotechnology, and they are widely used in the electronics, medicine, sensors, catalysis, and energy application. The reason for all this unusual property is the change in structure when the size of material is reduced to nanoscale. So before discussing the property, we must clearly understand the structural features of nanoparticles. Now, obvious question is, why do nanoparticles behave differently from bulk materials? There are three main reasons. First, the characteristics of size of nanoparticles became comparable to atomic and electronic length scales such as electron de Broglie wavelength. Second, in nanoparticles, surface atom dominate over bulk atom. A large fraction of atom lie on the surface. Third is due to the reason quantum confinement and surface effect become more important and strongly modify the structure. In bulk material, classical physics works well, but at nanoscale these effects cannot be ignored. Now let us understand what we mean by structural features. Structural features describe atomic arrangement, structure of crystal, defects and grain boundaries, shape and morphology. In bulk material, the properties are mainly governed by volume or interior atom. But in nanoparticle, the structural surface strongly influence the overall behavior because surface atoms are very less in number. So the fundamental difference is bulk material volume is dominator and nanoparticles surface is dominated. Here this slide shows the concept of size and surface dominance. Nanoparticles have extremely small dimension between 1 and 100 nanometer. Because of this small size, the surface to volume ratio becomes very high. This means that a large fraction of atoms are located on the surface. Surface atoms have unsatisfied or dangling bonds which makes them energetically unstable. To reduce surface energy, these atoms undergo surface relaxation and surface reconstruction, leading to changes in lattice spacing. In contrast, bulk materials have very few surface atoms, so the effects are negligible. Now let us discuss the crystal structure and defects. Nanoparticles are often found to be single crystalline or composed of very few grains. This formation of bulk dislocations requires a minimum size, so in nanoparticles bulk dislocations are generally reduced. However, because of this high surface area, surface defect increases and dominate the structure. In bulk material, on the other hand, are usually polycrystalline and contain many dislocations, vacancies and grain boundaries. Thus, the defect structure of nanoparticle is fundamentally different from the bulk material. Nanoparticles can exist in various shapes such as sphere, nanorods, nanotubes, nanoplates. The shape and morphology of nanoparticles play a very crucial role in determining their property. Different shape expose different crystallographic plane which have different surface energies. So shape directly influences structural stability and surface behavior. In bulk materials, shape does not strongly affect the internal atomic structure. Now, let us talk about structural stability. Due to high surface energy and surface atom rearrangement, nanoparticles experience lattice strain. Because of this strain, nanoparticles melt at low temperatures and the phase transition occur more easily. This means nanoparticles are less structurally stable compared to bulk material. Bulk material remain structurally stable because most atoms are well coordinated and surface effects are minimal. So this is the table which is comparing the nanoparticles and bulk material. And for first feature for size, for nanoparticle 1 to 100 nanometer, and for bulk material it is greater than 100 nanometer. And about surface to volume ratio, in nanoparticle it's very high and in bulk material it is very low. And crystalline feature, in nanoparticle it is single or few crystalline, and in bulk material it is made up of polycrystallines. And then surface atom, large fraction on surface in nanoparticle, and in bulk material mostly interior atom. Defects, in nanoparticles surface defect dominate, and in bulk material bulk defect dominate. And about the last one, about the structural stability, nanoparticles are less stable and having strained lattice, and in bulk material it is highly stable. To conclude my presentation, I would like to summarize the main ideas we discussed today. Nanoparticles are material whose size lies between 1 and 100 nanometers, and when material reach this scale, their structural features change significantly compared to bulk material. The most important structural features is large surface to volume ratio of nanoparticles. Because of this, a very large fraction of atoms are located on the surface rather than inside the material. These surface atoms have fewer neighboring atoms and hence possess higher surface energy. To minimize this energy, surface atoms undergo relaxation and reconstruction, which leads to lattice distortion and strain. As a result, nanoparticles often show single crystallinity, reduced bulk defect, increased surface defect, and lower structural stability when compared to a bulk material. In contrast, bulk materials are dominated by volume effect. Most atoms are well coordinated. Defects like dislocation and grain boundaries are common, and the crystal structure is highly stable. These structural differences are not just theoretical. They are the fundamental reason why nanoparticles exhibit novel mechanical property, optical and electrical property, magnetic and chemical properties that are absent in bulk material. For example, enhanced strength, size dependent band gap, unique optical color, and increased chemical reactivity all originate from the modified structure at nanoscale. Therefore, understanding the structural features of nanoparticle is extremely important for design and control synthesis of nanomaterials. For advanced technological applications such as catalysis, electronics, sensors, medical imaging, and energy device. Finally, we can say that structure forms the foundation of properties, and at nanoscale, even a small change in structure leads to significant change in material behavior. So, by controlling the size, shape, and surface structure of nanoparticle, we can engineer material with desired properties, which make nanoscience a powerful and promising field in modern physics. And these are the reference which I referred: S.K. Kulkarni and a PDS of MSU Nanoscience. And thank you. This ends my presentation.